chapter 2. Chapter 2 starts with dealing with describing the location in a distribution. Two ways to describe location are percentiles and z-scores. A percentile is the percent of values in a distribution that are less than the individual's data value. When you have a baby and you take them to the doctor, they weigh them, they measure them, they take their head size, and then they look on a chart and they tell you what percentile they are in for their height and their weight. A baby who is in the 80th percentile when they're born is heavier than 80% of babies that are born. A baby that's in the 20th percentile for weight when they're born is only heavier than 20% of babies that are born, meaning they're small, right? If you're in the 95th percentile for height, that means you're taller than 95% of people your age. Right? But if you're in the 10th percent for height, it means you're taller than 10% of people your age. So we have 25 scores from Mr. Pryor's statistics class on his first test. These are not your scores. I should have used your scores. Okay, so we have these scores. This bold score is Jenny's score. How did she perform on this test relative to her classmates? We're going to make a dot plot out of this data to figure this out. Okay, so here's a dot plot that shows the test scores. Jenny's score is marked in red. Okay. From this dot plot, we can see that Jenny's score is above the mean, right? The mean is the center. We can definitely see that the red dot is above the center. So she's above the mean, and she's the fourth highest score, right? To find her percentile, we're going to do the number of data values below Jenny divided by the total number of data values. So in general, it's going to be the number of data values below the one you want to find the percentile for, divided by the total data values. What's the total data values? 25 is our denominator. How many data values are below Jenny? That means you are not going to count Jenny's score. 21. Okay, all of these, there are 21 values below her, so her percentile is 21 out of 25, which is 84%. 0.84, 84%. So Jenny's score is the 84th percentile for her class. So what does that mean? That means Jenny scored higher than 84% of the class on this test. This is the same dot plot that we had on the other slides. I just wanted to make sure we had it on this screen as well. Find Norman's percentile if Norman scored a 72 on the test. Where is Norman's score? Norman, a 72 would be this score, right? Because this has got to be 72.5. So this has to be 72, 73, 74. So Norman, poor Norman, with his 72, which is passing. What is his percentile? Go ahead and find it. Okay, so it's the number of dots. The dots are the data values, right? We're not talking about the value of his score, just how many dots are below him. The number of dots below Norman divided by the number of dots. So how many dots are below Norman's score? 1. And out of 25, 0.04. Poor Norman is in the 4th percentile. So Norman scored better. Scored better than 4% of his class. Okay. And that's with a 72. So Maria was at the 48th percentile. What does that mean? What does that mean? Right. Write that down. Maria scored better than 48% of her class. Now, how can we find out what her score was? Yes, we need to find out how many numbers is 48% of 24, right? So 0.48 of 25, sorry, times 25 is 12. So the 12th dot, and then Maria would actually be the 13th, right? Because 12 of them are below her. So let's find Maria in this. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So Maria scored an 80. So 80 is about the middle, right? 80 is about the median because 48% is about halfway, right? So the median is around 80. Maria scored at about right smack in the middle of the class. I went up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's the P12 below Maria, and then that makes this her score. Okay, so this is the same graph, guys. The median of a distribution, the median is the 50th percentile, right? 50% of the data is below it, 50% of the data is above it. The first quartile is roughly the 25th percentile because it separates the lower 25% of values from the upper 25%. And likewise, the third quartile is roughly the 75th percentile, right? So we talked about that. 75% of the data is below Q3, 25% of it is above it. On the test, one of the questions asked what percent of values were at most, let's say at most, 84. That's an 84. What percent of values were at most 84? Well, at most means that's the highest value. So 75% of the values were below, right, that value of 84. That was the one I had to correct. We kind of knew that already. So, yes, definitely write this down. The z-score, also known as a standardized score, The standardized score for an individual value in a distribution tells us how many standard deviations from the mean the value falls, and in what direction. A positive z-score is above the mean. A negative z-score is below the mean. Let me put that down here. Okay, so the calculation for a z-score is the value, it's sometimes abbreviated x, minus the mean, abbreviated with x bar or mu. Mu is a Greek letter for m, mu. Both mean the mean, divided by the standard deviation. In the calculator, Sx, but also sigma. You're taking the difference from the value and the mean and dividing it by the standard deviation tells us how many of those standard deviations it is from the mean. Okay, so here we have the summary statistics for the test we are looking at and Jenny's score in 86. Where does it fall within the distribution in relation to her z-score? We knew it was the 84th percentile, but how many standard deviations is that from the mean? So 86 is going to be the value x. What is our mean? X bar? 80. And what is our standard deviation? What's the standard deviation? 6.07. So this is the information I need here to calculate z-score, just the mean and the standard deviation. So my z-score calculation, am I going too fast? Okay, the z-score is the x value, which is Jenny's score, minus the mean of 80, divided by the standard deviation, 6.07. Remember that you have to do the numerator first and then divide, so 6 divided by 6.07. If you try to put it all in your calculator without parentheses around the numerator, you're going to get the wrong answer because it's going to divide the 80 by 6.07 and then subtract that from the 86. So make sure you do the 86 minus 80. If you're going to do that in the calculator, not in your head, hit enter, and then divide by 6.07. And what do we get? 0.9 what? Give me 3 numbers behind the decimal point. 8. Thank you. So Jenny's score is 0.988 standard deviations from the mean. If it says find and interpret the z-score, that's your interpretation. Jenny's score is 0.988 standard deviations from the mean. All of our answers need to have context. Okay, so we don't want to just say it's 0.998, 0.988. We want to make sure our sentence tells what the problem is about. It's about Jenny's test score. Okay. One of the students, Lionel, earned a 67 on the test. Find and interpret that his z-score. So our value that we want to know about is 67. The mean is still 80. The standard deviation is still 6.07. So my z-score, 67 minus 80, divided by 6.07. Gentlemen, that's negative 13 divided by 6.07, which is negative 2.142, right? Because it's 1/6, the 6 rounds the 1 up. So how do we interpret?
Final score is negative 2.142 standard deviation from the mean.
From the mean. Okay. Maria scored the mean score. What does that make her z-score? No. 0. Who said 0? 0. If she is the mean, her score is no standard deviations from the mean because she scored the mean, right? If I did the z-score calculation, I get 80 minus 80 divided by 6.07 equals 0, which is 0. Maria's score is the mean. So it is 0 standard deviations from the mean. We need to use common sense. We need to think about what our answers should be ahead of time. What does it mean? Is my number lower or bigger? If it's lower, my z-score needs to be negative. So make sure you don't make those mistakes with negative signs. If it's bigger, then my z-score should be positive. Okay. So z-scores and percentiles allow us to compare performance when the scales are different. But we have to be really careful. A positive z-score is not always a better thing. And a large percentile is not always better. Can you think of some situations where a negative z-score or a low percentile is better than a high percentile and a positive, Delea? Right, diseases, right, or like blood pressure, right? You don't want to be in the 90th percentile for blood pressure or cholesterol, right? What else, Jeremy? Did you have one?
I had one, but she said it.
Anybody else have another example? In your class, you actually want to be in the 95th percentile, right? But a golf score, it's better to have a lower score, right, than to have a high score. So a golf score, a negative z-score is better. We want to be under par. That'll never happen, for me at least. Not over par. We want to be under the mean, not above the mean. Delea. Mileage on your car? Yep. The lower the mileage, right, the better. What about races? What kind of times do you want if you're in a swim race? You want a low time, right? You want a fast time. So you want to have a lower percentile or a lower z-score. So you really have to think about the context of the problem when you're doing a comparison, because sometimes a low z-score and a low percentile is better. Okay, so here's an example. We don't need to write all this down, okay? Jordan, so write down Jordan. Mr. Tabor, who is an author in the textbook, is 55 inches tall at age 9. Okay. The distribution of height for 9-year-old girls has a mean, so we want to write down this mean of 52.5 inches and a standard deviation of 2.5 inches. Okay, so Jordan is 55 inches. Don't write the paragraph, write the important information. The mean is 52.5 and the standard deviation for her age is 2.5. Zane, who is Mr. Starnes' grandson, also author of the book. Fun fact, I've taken classes from both of these guys in statistics when I've taken AP stuff.
Are they nice?
Yes, they are both very nice. Like, I could sit. So Zane, he is 58 inches tall at age 11. So Zane is 58 inches. The distribution of height for 11-year-old boys has a mean of 56.5 inches and a standard deviation of 3 inches. Who is taller relative to the other children of their sex and age? Jordan or Zane? Justify your answer. How might we compare who's actually taller relative to other kids in their age? Find their z-scores, right? Relative to the mean and the standard deviation, who is actually taller? So find both z-scores and tell me who you think is taller. Okay, so let's look at Jordan's calculation. Sometimes if I'm writing more than one z-score, I might put a little subscript to remind me like what one I'm talking about, where I have it. So the z-score for Jordan, the subscript J, is 55, her height first, minus the mean, 52.5 over 2.5, and I get 1, right? 2.5 divided by 2.5. And the z-score for Zane is 58 minus 56.5 over 3, which is 1.5 over 3, which is 0.5. So who is taller? Jordan is taller relative to other children because her height is 1 standard deviation. You can abbreviate a little bit here and there from the mean. And Zane is only 0.5 standard deviations from the mean.